Okay, so number one, let's suppose we had this linear equation. Y equals 3x minus 1. Now remember, we're dealing with linear equations. What makes it linear is the fact that I can write in the form ax plus by equals c. So all linear equations can be written in this form. So notice what makes this linear also is the fact that the variables x and y are both being raised to what power?
1.
The first power. All right, so they're both being raised to the first power. That makes it linear. So that's a linear equation. In the word linear, what other word do you see? Line. So you see the word line. All right, so whenever y is by itself, and the ones that you have in my math lab and the ones that you have in the worksheet, y is by itself. So whenever y is by itself, the way they want you to do in my math lab is to use a t-table. They use a t-table, just like this. So you have your x column, you have your y column. Now since y is by itself, basically what you're going to do is find some values for x. So for example, if x is 0, I get y equals, and wherever you see the variable x, what do you plug in?
0.
So I get 3 times 0 minus 1, and then 3 times 0 is 0. 0 minus 1 is a negative 1. All right, so when x is 0, your y value is negative 1. So you're finding points on this line. That's what you're finding. Now these are also solutions. So remember, these are solutions as well. These are solutions. So every point on that line is a solution, which kind of makes sense because if I substitute these values to here, remember a solution of an equation is a number that makes the equation a true statement. So the left side is going to equal the right side. So the question is the point 0, negative 1 a solution to this equation? Well, wherever we see the variable x, what do I plug in? 0. Wherever we see the variable y, what do you plug in? All right, so I get negative 1 equals 3 times 0 minus 1. Well, what's 3 times 0?
0.
And 0 minus 1 is a negative 1. So is that a true statement? Yeah. So those are solutions. Every one of these that we find is a solution. All right, now you may remember to graph a line, you need at least how many points? 2. You need at least 2 points, but always use 3 just in case you made an error at one of them. Because remember, all the points have to lie in the same line. So give me another number for x.
1.
1. So if x is 1, I get y equals 3 times 1 minus 1. Remember, order of operation, you multiply before you subtract. 3 times 1 is 3. 3 minus 1 is 2. So when x is 1, what's my y value? 2. So I found another point on the line, and that point is also a solution. These are all solutions. All right, now I could have made an error at one of these. So let's use another point. So give me another point for x. Give me a negative value. Negative 2. Okay, so if x is negative 2, I get y equals 3 times negative 2 minus 1. What's 3 times negative 2? Negative 6 minus 1 is a negative 7. All right, so these are all solutions. Now we got to plot those 3 points. All right, so let's go ahead and plot those 3 points. So I'm going to plot the point 0, negative 1. Remember, to plot a point, you always start at what point on the coordinate plane? The origin. So the origin, remember, is where the x and the y-axis intercept. So I need to plot the point 0, negative 1. So since x is 0, where do I go? No. Since x is 0, where do I go? I stay at the origin. Y is negative 1, so I go where? Down 1. So this is a point 0, negative 1. Now if it says label, and for those of you that downloaded the worksheet, did it say label? Okay, so if it says label, what does that mean? You indicate what those coordinates are. So plotting the point is not labeling. This is not labeling. Labeling is where you actually say 0, negative 1. That's labeling. All right, so make sure you read the directions carefully when you do the worksheets. Okay, what's the other point we need to plot? 1, 2? All right, so you start the origin. X is 1. Where do I go? To the right 1. Y is 2. Up 2. So there's the point. I'm going to label it 1, 2. And then we also did negative 2, negative 7. So negative 2, negative 7. So you go to the left 2 and what? Down 7. So negative 2, negative 7. And then you take a straight edge. And if you need a ruler, I have a ruler. So you draw your line. And when you draw a line, make sure you extend it. Extend it through your points. And then what else must I draw? The arrows. So make sure you draw your arrows. All right, now on the worksheet in my math lab, they're going to want you to do this by using a t-table. You also learned in Math 98, 2 semesters ago, how to graph the line using slope and intercept. All right, so remember, whenever you get the equation with y by itself, y equals mx plus b, that's what form right here? Do you remember? Slope-intercept form. And you graphed linear equations 2 semesters ago where you had to use the slope and the y-intercept. That's not what they want you to use here. They want you to use a t-table. So at some point, I'll give you a worksheet where the equation will be in slope-intercept form and ask you to use the slope and the y-intercept. But that's not what this is. So when you do the worksheet, don't use the slope and the intercept. Use a t-table. Okay? So that's slope-intercept form. So remember where m is the slope and the constant is your y-intercept. So you may remember something like that from 98, Math 98. All right, so that's the equation, y equals 3x minus 1. Now let's look at the other equation. So the other equation is similar to the one that's on your worksheet. Okay, so that's number 2. You have y equals negative 3/5 x plus 2. All right, so that's a linear equation because both x and y are being raised to the first power. So when I graph it, it's going to be a line. Y is by itself, so let's use a t-table. Now, since y is by itself, it's also in slope-intercept form, but they want you to use a t-table, so make sure you do a t-table. What's the easiest number to use for x? 0. 0. So if x is 0, I get y equals negative 3/5 times 0 plus 2. What's negative 3/5 times 0?
0.
And what's 0 plus 2? 2. So I found a point on the line. I found a solution to this equation. And so one of the solutions is 0, 2. So let's just go ahead and plot that point right now. So 0, 2 is on the positive y-axis. Now before I go on, how many points are on this line right here that I just drew? Nope.
Infinite.
An infinite number. Everything shaded is a solution. I just used 3 to graph it. But there are not 3 points on that line. There are how many points on that line? An infinite number. Isn't this point on that line that I'm pointing to?
Yeah.
Isn't this point on that line that I'm pointing to? Is this point on that line that I'm pointing to? Yeah, so they're all solutions. Is this point that I'm pointing to right here, is that a solution?
No.
No. Why is that not a solution?
It doesn't lie on the line.
It does not lie in the line. All right? But there's an infinite number of solutions, an infinite number of points on this line. I'm just using 3 of them to graph it. All right, now notice the difference between number 1 and number 2. So number 1, the coefficient of x, the slope, is 3. Here, what's the slope? It's a fraction, negative 3/5. So be strategic with the numbers you use for x. If the coefficient is a fraction, if the slope is a fraction. Do you remember what you wanted to use for x in this case?
0.
We already did 0.
What?
No, if you use 1, here's what's going to happen. If you use 1, you're going to say, well, negative 3/5 times 1, that's an easy one, that's negative 3/5. But then you would have to add 2, so then you have to find the common denominator and all that. Remember that?
Mm-hmm.
So make it easy on yourself. Use numbers for x that are divisible by this denominator. So what numbers are divisible by 5? 0, what else? 5, what else? Negative 5, what else?
10.
10, negative 10, and so on, right? So when the coefficient of x is a fraction, choose numbers that are divisible by that fraction, by that denominator. So that way you don't have to worry about adding fractions. You have to worry about finding the LCD or anything like that. So notice what happens when I let x be 5. When I let x be 5, I get y equals negative 3/5 times 5 plus 2. All right, so remember, order of operations, you're going to multiply before you add. When I multiply, I get negative 3/5 times 5, and we write 5 as 5 over 1. Now, one of the things you learn to do when multiplying fractions is to reduce. It makes things a lot easier if you reduce first. You got to know how to reduce. Can I reduce anything here? You better say yes, because that was the whole point of multiplying by 5. Was because this denominator was divisible into it. So 5 and a 5 is 1. 5 and a 5 is 1. Now let's multiply the numerators. What's negative 3 times 1? The denominator, what's 1 times 1? What do I get? Negative 3. Now be careful. Don't put negative 3 here. That's just this. Now, remember, you could have also multiplied first, but you need to know how to reduce first as well. If you multiply first, what's negative 3 times 5? Negative 15. What's 5 times 1? 5. Do I still get, that's a 5. Do I still get negative 3? Yes. All right, but it does help if you reduce first. All right, and then finally, what's negative 3 plus 2? Negative 1, so that's equal to negative 1. All right, now I could have made a mistake, so always use another point. So if x is negative 5, I get y equals negative 3/5 times negative 5 plus 2. All right, let's do the order of operations. So we're going to multiply first. You got to remember, negative times a negative is a positive. So that's going to be a positive right here. All right, so let's figure out what negative 3/5 times a negative 5 over 1 is. 5 and a 5 is 1. 5 and negative 5 is a negative 1. What's a negative 3 times a negative 1? Positive 3. What's 1 times 1? So that's just 3. So I get 3 plus 2, which is 5. All right. So I just need to find 3 points of that line. And again, how many points are on this line? An infinite number. I just found 3 of them, and those are all solutions. All right, and so you just got those 3 points. We did one already. 5, negative 1. 5, negative 1. You start the origin, you go which way? To the right 5, and then what? Down 1. 5, negative 1. So that's 5, negative 1. You label. And then what's the other one? Negative 5, 5. So negative 5, I go to the left 5, and then it was 5. I'm sorry, negative 5, 5, right?
Yeah.
So go to the left 5 and then up 5. So there's the point. 5. Oops, sorry, negative 5, 5. All right, and then use your ruler, draw your line. Make sure you extend it. And you get this. So that's the line, y equals negative 3/5 x plus 2. All right. Okay, now what kind of equations were these? Linear. Okay, now let's see if you remember something from last semester. All right, from last semester, let's suppose I want to graph this equation. Okay, graph y equals x squared minus 3. First of all, is this linear? Is this a linear equation? No, it's not a linear equation. In order to be linear, both the exponents of y and x have to be raised to what power? 1. Do you remember what kind of equation this is? Quadratic. Very good. So that's a quadratic equation. All right. So when you have a quadratic equation, and let's call it quadratic function as well. So quadratic equation, function. Now we're going to do more with quadratic functions in a later chapter. When we do that, we're going to talk about axis of symmetry. We're going to talk about x-intercepts, y-intercepts, increasing, decreasing, and all that. So that's going to be in a separate chapter. For this, though, you're just using something you learned from last semester and the semester before that. This is quadratic equation, quadratic function. What does the graph look like? What's that graph called? What's it called, though? It has a name to it. Like for example, this was a line. You remember what that one is? A parabola. Parabola. So the graph is a parabola. P-R-A-B-O-L-A. Graph is a parabola. All right. And we're going to learn about how to find the vertex of any quadratic function later on. But in my math lab, when you do this section of my math lab, they're going to give you the t-table. The t-table will already be there. Now remember, this is not a line, right? If this was a line, you need at least how many points to graph a line? 2, but we use 3 just in case you made an error. When graphing a quadratic function, you need more than 2 points. You need more than 3 points. So in my math lab for right now, they're going to give you the x values they want you to use. So they're going to tell you they want you to use 0, 1, -1, 2, and -2. So they will give you the t-table. And on that worksheet, I think I gave you the t-table if you downloaded it. I gave you the t-table for these quadratic functions. And so all you do, where we see the variable x, you plug in the value that's there. So if x is 0, I get y equals 0 squared minus 3. Remember, order of operations, what do you do first? Exponent before you subtract. What's 0 times itself? And then 0 minus 3 is a -3. So my y coordinate is -3. If x is 1, I get y equal 1 squared minus 3. What's 1 squared? What's 1 times 1? 1 subtract 3 is a -2. If x is -1, now notice I put parentheses around this 1. It was not necessary. I could have just said 1 squared minus 3. Because this base right here is understood to be 1. 1 times 1 is 1. But remember, there is a difference between 3 squared, -3 in parentheses squared versus this. There's a difference between those two. In this one here that I'm pointing to, what's being squared? -3, the base. So that means -3 times itself, which is 9, +9. Over here, what's being squared? 3 only. So this is what you do first. So what's 3 squared? 9, but it becomes a -9. All right, so there's a difference between the two. So when I substitute x, notice I'm going to write it mathematically correct. I'm not going to say this. The way I'm writing it here is incorrect. Because if I write it like that, that means what is being squared? 1 only. What should be squared? -1. So what do I need? Parentheses. All right. Now that means -1 times -1, which is what? 1. And what's 1 minus 3? -2. Right. And let's do 2. When x is 2, I get y equal 2 squared minus 3. Did I need parentheses around 2? No, because it was positive, right? I did not need it. What's 2 squared? And then what's 4 subtract 3? 1. So I get the y value to be 1. If x is -2, I get y equals, do I need parentheses? Yes. -2 squared minus 3. What's -2 squared? 4. What's 4 subtract 3? 1. All right. Now you're going to notice that, see how these x values, they were opposites, but the y values were the same? And there's a reason for that, and you can learn about that again in another chapter. But that has to do with symmetry. Now, what I want you to do, and it doesn't matter if you use the back page or if you use the larger grid. Does not matter. So take out one of your grid papers. If you need some more, the smaller graph paper, it's right there. Just go ahead and get some more if you need it. But you do have a back side to it. But there's enough, the points are small enough to where it will fit in one of the smaller grids. So you don't need the big graph paper. So 0, -3, I'll start at the origin and go where? Down 3. So that's 0, -3. 1, -2 is right here, correct? So that's 1, -2. -1, -2 is right here. 2, 1 is right here. -2, 1 is right here. And I'm gonna go ahead and let x be 3, just to see what that point will look like. So if x is 3, I get y equals 3 squared minus 3, so that's what? 9 minus 3, which is 6. Okay. If x is -3, I get y equals -3 squared minus 3. What's -3 times itself? 9 minus 3 is 6 as well, right? So I get 3, 6, and -3, 6. So 3, 6, and -3, 6. So I just use an extra pair of points. And notice when you graph it, just make sure it looks like a parabola. Just do the best you can with drawing this curve. These are not segments, these are curves. Just do the best you can with drawing these. Make sure you use a pencil, that way you can erase if you need to. All right. So that's what the parabola looks like. That's what a parabola should look like. Now, you see that lowest point right here? This lowest point? What's the lowest point of the graph?
1,
-2. What's that called? Do you remember?
Vertex.
The vertex. That's called the vertex. So the lowest point, see how the parabola goes from decreasing to increasing? So that small point, that minimum point, is called the vertex. Now if it went down like this, then it would have a, what kind of point? Not minimum, but a what? Maximum point, and that would be the vertex as well. Okay? So the vertex of a parabola is where the minimum point is or the maximum point is. You can only have one. Okay? Now, we're going to, in a later section, we're going to talk about the axis of symmetry. The axis of symmetry. So I want you to notice for right now, though, you don't have to know this for Math Lab, but if you look at the y-axis right here, like let's say this ruler is over the y-axis. Do you see how this parabola is symmetrical about the axis of symmetry, the y-axis? So if I were to fold this side about the y-axis, I would get this side. And notice that these distances, the distance from here to here is the same as the distance from here to here. So you see how from the y-axis, how many units is this right here that I'm looking at? 3. So how many units should this be? 3. How many units is this? 2. How many units should this be? 2. All right, so we're going to talk about axis of symmetry in a later section. The equations become more complicated. This equation right here is not that difficult to graph, but they do become complicated. So there are formulas for finding these. All right, one more with this. Let's look at this one instead. So we say that this parabola opened up. See how the arrows are pointing up? So it opens up. Let's look at one where the parabola opens down. So let's look at this one. So let's go ahead and graph y equals 4, minus x squared. Y equals 4 minus x squared. All right, we're going to use the t-table again. So we're going to use 0, 1, -1, 2, and -2. Now, is this a linear or a quadratic function? It's quadratic. Because what do you see for, first of all, the coefficient, the exponent of y is what? Exponent of y is what? 1. The exponent of x is what? 2. So that's what makes it quadratic, is the exponent of x. So the exponent of x is 2. If both of them were squared, it could be a circle, depending on what the sign of both the x and the y is. So we're going to talk about circles in another section. So we're going to look at equations for circles soon. But since y is being raised to the first power, and since x is being raised to the second power, that's quadratic. The one you're going to learn probably the end of next class period maybe, is that if they're both being raised to the second power, that's a circle. So you're going to see how to graph that. It's very easy to graph. It's not difficult. All right, but this is quadratic. Y'all agree? That's quadratic. So that means that the graph is going to be the shape of a parabola. All right, so if x is 0, I get y equals 4 minus 0 squared. And if you want to put parentheses, you can. Does not matter, but you do need them for the negative x's, though. What's 0 times itself? So 4 minus 0 is 4. All right, so I found a point on that quadratic function. I found a point on the parabola. If x is 1, I get y equals 4 minus 1 squared. What's 1 squared? And what's 4 minus 1? 3. I get 1, 3. If x is -1, I get y equals 4 minus the -1 squared. What's a -1 times itself? Remember, you do the exponent first, right? You do the exponent before you subtract. So cover this part up right here and tell me what -1 times itself is. 1. So this becomes 4 minus what? 1, which is what? 3. If x is 2, I get y equals 4 minus, in parentheses, 2 squared. What do I do first? The exponent. So what's 2 squared? So I get 4 minus 4, which is 0. If x is -2, I get y equals 4 minus a -2 squared. What's being squared? -2. What's -2 times itself? That becomes 4 minus 4, which is 0. All right. So then let's go ahead and plot those points. Let's see what we get. So 0, 4 is here. 1, 3. I go to the right 1, up 3. -1, 3. I go to the left 1, up 3. 2, 0. And then -2, 0. Now, if you wanted to do another 2 points like -3 for x, you can. But that's all they ask you to do. So you just draw a parabola, make sure it looks like a parabola, something like this. Make it look symmetrical about the y-axis. Make it look symmetrical. Okay, so something like that. Make it look symmetrical. And the maximum point, this point right here, again, what's that point called? The vertex. Vertex. And notice that this parabola opens up or opens down? Opens down. Parabola opens down. When we get into that chapter dealing with quadratic functions, where you have to graph these quadratic functions, what makes it open down and open up is this. So if I go back to the one we just did, y equals x squared minus 3, what makes it open up is that the coefficient of x squared right here is positive. So that's a +1. It's positive. So that's what makes it open up. No,
Coefficient of X is positive.
the coefficient of x, yeah, well, if you look at x squared right here, this is a 1. All right, here, the coefficient of x squared, the number in front of x squared, I should say, is a negative 1. All right, so that's going to open down. So what's going to happen when we get into that chapter is you're going to have this. You're going to have y equal negative 2x squared minus 5x plus 3. You're going to have y equal something like, let's say, 3x squared plus 2x minus 1. So you're going to have to graph these quadratic functions. Now notice those look a lot more complicated than what we just did, right? And they are. But there's some formulas that can help you when we get to that part. I'm going to ask you this. Does this parabola open up or down that I'm pointing to? Opens down because the coefficient of x squared is negative. So it opens down. Here, will the parabola open up or down? Opens up because the coefficient of x squared is positive. Positive. So it opens up. All right, so you're going to see that when we get into that part later on. Okay? All right. Now, the other thing we want to look at in this section, and we're almost done with this section, is x and y intercepts. Now, when I go back and I look at, see this point right here? If I ask you to label that point, what is this point right here? How would you label it? 2, 0. If you look at this point right here and I ask you to label it, what is it? Negative 2, 0. If I ask you to label the vertex, what's the vertex? No, but what is it here? 0, comma 4, right? Okay. And over here, well, you really can't. You would have to estimate what these what the x coordinates are here. So I'm not going to even worry about that. But remember, this point that I'm pointing to right here, this point and this point, that's where the graph does what? Cross the x-axis. That's where the graph crosses the x-axis. This point right here is where the graph does what? Cross the y-axis. So where the graph crosses the x-axis, those points are called the x-intercept. So how many x-intercepts are here? How many x-intercepts? 2. Because the graph crosses the x-axis in 2 places. This is called the y-intercept. So that's called the y-intercept because that's where the graph crosses the y-axis. Now remember something else from a previous course, that when you're looking at the x-intercept, wherever the graph crosses the x-axis, what do you notice about your y-coordinates? They're always 0. No matter where you are on the y-axis, so if you look at this y-intercept, no matter where you are on the y-axis, what is the x-coordinate? 0. Okay. Just wanted to remind you about that. All right. Now I'm going to pass out a sheet of paper with some graphs on it. Okay, so now we're going to look at, you're given some graphs, and you're just asked to determine what the intercepts are. Okay, so remember, the x-intercept is where the graph crosses or touches the x-axis. Okay? The y-intercept, that's where the graph crosses or touches which axis? The y-axis. So the x-intercept is where the graph crosses or touches the x-axis. The y-intercept is where it touches or crosses the y-axis. So if you look at that first one, that first line right here, now if there's no numbers on the grid lines, assume each one's a unit. Each one's a unit. So notice that this line, this point that I'm pointing to, that's called the what? X-intercept. So tell me what that x-intercept is. 5, 0. So that's your x-intercept. So the x-intercept is 5, 0. Now, when you look at the worksheet, there's going to be the word x-intercept with a line, with a blank. If it says an ordered pair, and I think it does in the worksheet, if it says an ordered pair, the word ordered pair, that means write it as x comma y. X comma y. So did I write this as an ordered pair?
Yes.
Yes, because x is 5, what's y? 0. Now my math lab, is just going to say, find the x-intercept. In that case, if it just says the x-intercept, then in that case, you're going to say this. You're just going to say 5. Okay? If it says ordered pair, what do you have to write?
50.
50. So on the worksheet, you have to do this. On my math lab, you have to do this. You just write 5. All right. What is the y-intercept?
40.
Not 40,
04.
04. Okay, make sure you put the 0 in the right place. So the y-intercept is 0, 4 in this case. So that's your y-intercept. So I wrote the y-intercept as an ordered pair. If it doesn't say anything about an ordered pair, you just say what? 4. You just say 4. Okay? All right. Now, this line is a horizontal line right here. So I'm going to ask you what the x-intercept is. You're going to say what? I'm asking you for the x-intercept. What are you going to say? There is none. There is none, right? Does this graph cross the x-axis? No, it only crosses which axis? The y-axis. Now, if you look at this, no matter where if I draw this horizontal line here, does it cross the x-axis? It's only going to cross the what? So here's the question. Listen to the question before you answer. Do all horizontal lines cross the y-axis? Yes. Do all horizontal lines, be careful with your answer, do all horizontal lines cross the x-axis?
No. Yes. No.
Okay, the answer to all is no. All right, what if I asked you this? Does at least one horizontal line cross the x-axis?
Yes.
Yes, it's this one here, y equals 0. All right, so that's the only horizontal line that crosses the x-axis. In fact, how many x-intercepts are here if it did? An infinite number. All right, but for this one, there are no x-intercepts. And then what is the y-intercept as an ordered pair? 0, 2. If it didn't say anything about an ordered pair, you would just say what? 2. All right, look at the vertical line. It definitely, if it does not have a what?
Y.
Y-intercept. So you'd say y-intercept none. What is the x-intercept as an ordered pair? What's that? What is it? 7, 0? 7, 0, right? 7, 0. Y'all agree? All right. Look at that parabola over here. How many x-intercepts are there? 2. All right. Now, let's talk about my math lab. On my math lab, remember, my math lab, they're not going to ask you to write in ordered pair. So here's the way you're going to write your answers. First of all, give me one x-intercept. 1. All right, so you're going to say 1, comma, and no, not as an ordered pair, just 1. Just say 1. What's the other x-intercept? -3. So in my math lab, that's how you're going to write your answer. Don't put parentheses. If you put parentheses, you're saying that's an ordered pair. So in my math lab, be a little bit careful. Don't put parentheses. You put parentheses, you're saying that's the point 1, -3, which it's not, because 1, -3 is in the first quadrant. I'm sorry, it's in the fourth quadrant, 1, -3. All right, so that's my math lab. On your worksheet, you're going to write an ordered pair. So what's one point in parentheses? 1, 0, and what's the other? -3, 0. Okay? All right, so notice how to write those. My math lab says there are two of them. You separate it by a comma. On the worksheet, you use an ordered pair. On my math lab, how would you indicate the y-intercept?
0,
No, the y-intercept.
3,
3. How would you indicate the y-intercept on the worksheet? 0, 3. Ordered pair. Okay, so notice the difference between ordered pair versus not an ordered pair. Okay? All right, look at this one. So you're going to graph some polynomials that look like this later on towards the end of the semester.
I like it.
How many x-intercepts are there? 3. In my math lab, how are you going to write those x-intercepts? Let's go from left to right. What's the first one? -3, comma. -1, comma. And then what? 2. So that's how you're going to write it in my math lab. -3, comma, -1, comma, 2, comma. Okay? On the worksheet, you're going to write them as ordered pairs. So you're going to say -3 in parentheses, 0. What's the next one? -1, 0. And what's the next one? 2, 0. All right. The y-intercept, on my math lab, what are you going to write? -6. On the worksheet, you're going to say 0, -6. Okay, and on the last one, what is the y-intercept? Let's do the y-intercept. What's the y-intercept? 3? 1, 2, okay. 3, so you can say 3, or you're going to say what? 0, 3. The y-intercept, I'm sorry, x-intercept. How many are there? 2, because remember, it's where it crosses or it touches. So it crosses here, touches here. So in my math lab, you're going to write it as -2, comma, 1. On the worksheet, you're going to say -2, 0, and 1, 0. Okay? So that takes care of this particular section, section 1.1.